As it's time to start, yes. Welcome to our session. Our session is, the theme of our session is conservation of landscape utilizing AHS. So, and as you know, we don't have enough time, so we have to start now. And let me start introducing myself. My name is Yuno Park from Korea. I'm Secretary General of ＥRAHS Korea. Nice to meet you. And we have 5 speakers in 80 minutes, so we don't have enough time to discussing or Q&A time. You can have like the kinds of time. So after, if you have any questions, you can personally ask to the speakers, please. Yeah. Let's start. The first speaker is Professor Lee Yu-jik from Korea.
The topic I present today is 2 thoughts on the modern transformation of Korea's agricultural heritage landscape in Korea. Today, I would like to talk about the 2 things related to the conservation of the landscape of agricultural heritage area, a little casual, not seriously. The one is that the landscape has many implications. The other is that the landscape has historically undergone great changes in Korea. And though through the Japanese colonial period, modernization and industrialization, the Korean rural landscape has changed a lot. And this change is still ongoing. I believe that a clear understanding of these 2 aspects is an important starting point for the conservation of agricultural heritage landscapes. First, let me say the concept of a landscape is ambiguous. This lies through the etymology of landscape. The English word landscape includes the etymology of landscape and Landschaft. Landscape, which means aesthetic and visual aspects, and the Landschaft, which has environmental or ecological implications. In some cases, we call landscape planning as 경관계획, and Landschaft planning in Korea, 환경생태계획. This is the same alphabet, but we call different ways in Korea. So landscape possesses 2 seemingly contradictory properties at the same time, so it is ambiguous to us. Let's take a quick look at history about landscape painting. Under the influence of landscape painting, Italian landscape painting in the 16th or 17th centuries, landscape was considered an ideal scenery for visual appreciations. Understanding landscape as scenery resulted in the word landscape losing its properties as an environment and focusing on a 2-dimensional pictorial effect. Landscape ecology, which emerged in the 1980s, interpreted landscape as mosaic-like, uneven spaces made up of elements called patches. From this viewpoint, landscapes are composed of 3 main elements: patches, boundaries, and corridors. And all of these are interpreted as being within the landscape matrix. Landscape urbanism, which emerged in the 1990s, understands the landscape as a matrix, like a nervous system. encompassing not only objects and species, but also dynamic processes and events, then runs through them. It is understood as a field that accommodates the evolution and creation of the city, including buildings, roads, open spaces, and infrastructures. While landscape painting understood the landscape as a picture, the viewpoint of landscape ecology and landscape urbanism understand the landscape as land or surfaces. This viewpoint is also connected to the GIS systems operated by FAO. This is because GIS considered changes in agricultural landscapes as changes in land use. It approaches changes in landscape from the perspective of land use. This viewpoint is also reflected in the GIS application guidelines. The guidelines recommended that estimating landscape changes by tracking which types of land use are dominant in a given way. The second thing is that the rural landscape in Korea has undergone great changes since late Joseon dynasty through the Japanese colonial period and the era of modernization and industrialization. And this change is still ongoing. These changes make it difficult to judge the historical and traditional nature of agricultural heritage landscapes. This is because extensive changes in farming methods, seeds, and agricultural production methods occurring during this period. This change is a phenomenon of entire Korea rural landscapes. And because of this is a debate about whether this change is a development of successions of tradition or a break with the tradition. So let me briefly share my thought on these two issues. I think it is desirable to track changes in landscape with changes in land use. However, there are technical and economic problems. Because the alteration of land use occurs over a wide area and over a long period of time. So tracking and responding to these changes is actually very difficult. So solutions to this problem should be considered along with the development of agricultural heritage monitoring and evaluation system, which was discussed this morning by Mr. Endo. It is true that monitoring and evaluation of agricultural heritage are less rigorous than other heritage systems or geopark systems. So it is necessary to develop a more efficient and practical method for agricultural heritage landscape monitoring. When tracking landscape changes in agricultural heritage site areas, it would be desirable to focus certain areas certain core areas, and how often and at what frequencies to be considered as well. In addition, regular and continuous monitoring as well as policy responses are required. Let's move to the second issues. The problem of changes in the agricultural heritage landscapes that occurred through the colonial period and modernization and industrialization is as I said to you before, overall and structural problems of Korea rural landscape in these days. This is because extensive changes occurred during this period, and farming methods, introductions of foreign species, and changes in agricultural production method, and so on. So the important point is whether these changes can be accepted in terms of dynamic conservation. Agricultural heritage system is living heritage, and we value that it is still ongoing, alive. However, dynamic conservation must be carried out at a level that does not damage the historical, ecological, and agricultural or landscape values of the heritage sites. So in this respect, dynamic conservation in Korea is likely to be controversial in many aspects. It is very ambiguous and difficult to set the boundaries of how much dynamic conservation can be accepted and where it cannot. In many cases, there is a high possibility of conflict of opinion between residents or experts, residents and experts. Therefore, continue discussions among agricultural heritage stakeholders on this issue will be necessary. Okay. Today, I'm not making this presentation today to present any result or conclusions. Just rather, the goal is to publicize the structural problems of the agricultural heritage system, especially in Korea, and to identify the issues. What is clear is that the conservation of agricultural heritage systems and the conservation of landscape should head in the same direction. I hope that the experience of 3 countries in conserving landscape, the use of agricultural heritage, which is also the topic of this session today, will continue to be exchanged more and more through ＥRAHS. Thank you for listening.
Thank you, Professor Lee. Thank you for keep the time. And the second speaker is Mr. Tasaki Tomonori from Japan. Yes, please welcome the presenter with applause.
Good afternoon, everyone, and Tajahao and 안녕하세요. 皆さんこんにちは. I am Tomonori Tasaki, and I come from Takachiho town in Japan, which is one of the GIS side. And thank you very much for giving me this opportunity to have a presentation here. And it's my great honor to stand here. So in my presentation, I would like to cover the brief introduction of our site and what kind of action we have taken in these 10 years after the designation. Okay, so this is about the overview of our site. The name is Takachihogo Shibayama. Our site is located in the center of Kyushu Island. It's not. And we have 3 towns and 2 villages, and that is Takachiho Town, Hinokage Town, Gokase Town, Morotsuka Village, and Shiba Village. And the population is about 20,000. And among the area, 92% occupies forest. And as the population forecast on the graph shows, in next 20 years, the population of our site will be almost half in next 20 years. So we have been facing a serious decreasing in population and also aging society as well. And this is a landscape in April in our side. So we have the mountains and we have the rice field, and also we have the houses and village around the rice field. And on the center there's a gorge and the river running along the gorge. And one of the key factor of our site is the water irrigation system to supply the water to rice field. And on the mountainside there is a irrigation running on the side, and also there is another irrigation running on the side. So there are many lines in our site, and when we sum up all of the irrigation, the total length will be about 500 kilometers in our side. And the name of our system is technically called Composite Management System of Agriculture Forestry, which means one farmer grows multiple products in a year. For example, in spring we plant rice, and in summer we harvest vegetables such as eggplant, tomatoes, and green teas, and etc. And in autumn we harvest rice, and in winter we harvest shiitake mushrooms, flowers, and some other fruits. And in entire season, all season, we feed cows there for beef. Yes, and as mentioned before, 92% of our site occupies forest. We don't have much flat land, so we have no choice but to have multiple products depending on the season to make our livings. And this is the agriculture and forestry output of our site in a recent year. Beef occupies 4.2 billion yen, which is 42 oku yen in Japanese, and forestry occupies 3.2 billion. And there are rice, vegetables, fruits, flowers, and other products as well. And from this slide, I will mention some project or action which were implemented after the designation of GIAS. This is about the collaboration with Miyazaki University GIAS research team. Based on the GIAS partnership agreement, we support the GIAS research team from Miyazaki University to conduct academic surveys. More than 40 surveys have been conducted in these years, and also the GIAS research team has host research presentation to local people every year. And we believe that it is important to have an academic evidence to prove that our site is very unique and outstanding as a GIAS site. And this slide is about the GIAS Academy, which means the GIAS education program for youth. This is a program where students from Takachiho High School and Gokase Secondary School learn about GIAS, and they write articles about what they have learned on web media. And some students visit elementary school and junior high school and teach about GIAS to the students there. So most of the students from not only these two high schools, but also other elementary school and junior high schools have an opportunity to learn about GIAS in their school. And this is about the Takachiho Farmers School, which was launched in 2022. This is a system designed to support individuals aiming to start new agricultural venture in Takachiho by providing technical assistance from advanced farmers and also financial support. The training period is 2 years, and the living support and preparation for farming will be backed up with collaboration with relevant organizations such as JA and prefecture government. And after the town opened the school, some people have joined the school and they are aiming to start their farming in the near future. And this is about the Takachiho Rice Paddy Camp. This is also started in 2022. In this paddy camp, guests can have a camp at Rice Paddy in Takachiho town. And this is run by a private company. And the company offers a fixed rate subscription for membership. Guests can have a camp anytime during the winter. And some amount of the revenue by this camp are reinvested to the local community. And also this is about the new local specialties with GIAS. Some dessert from with local green tea have been produced just this year. They are available for purchase online and at the airport at this moment. And these products were produced by GIAS business manager who were hired last year. The picture above is green tea terrine. It's 3,300 yen. And the picture below is green tea ganache. It's 2,700 yen. And this is about the future vision of our site. Our GIAS Promotion Association have been working on creating the future vision of our site since last year. So we will create its final version, hopefully this year. And our site will celebrate 10 years anniversary of GIAS designation next year. And this vision will be quite significant for welcoming the next 10 years. Okay, so this is the last thing. I'd like to show some key indexes from our action plan, and I'd like to show you how things have been changing in recent years. The first one is about the number of new farmers in recent year. There are 21 new farmers in 2020, and 18 in 2021, and 21 in 2022. So which means each town and village has some support system to start farming, and there are a certain number of new farmers every year. And third one is about the number of Kagura group, preservation group in our site. So in our site we have a traditional dance, I don't say dance, it's a ritual performance to pray for God, to pray for good harvest. And there are 97 group in 2019, and the number has not changed in these years. So which means the number of the group does not change. So I believe that this means that we have a local community which have a strong will to preserve and perform Kagura in our site. And the fourth one is about the agriculture output. It's about 11 billion yen in 2017 and 10 billion yen in 2021. So I can see the slight decrease in these years. So our site has been facing depopulation, and its some negative impact are actually confirmed. So I believe that dynamic conservation is fundamental to make our agriculture system more sustainable. And so this is the end of my presentation. So as I mentioned, our site will celebrate the 10 years anniversary next year, and we are planning to have a ceremony maybe around in autumn, the end of October or the beginning of November in 2025. So it will be a great pleasure to meet you at 10th anniversary in 2025 in Takachiho town. And yes, and I also hope this conference will be the good opportunity for all of us here. Thank you very much for listening, and 谢谢大家 and 감사합니다, and ご清聴ありがとうございました。
Thank you. But actually, we have 3 minutes, so if you have any questions to presenter, any questions? No? Okay, let's move to the next one. Yes, thank you, Mr. Tasaki Tomonori. And the third speaker is Dr. Wada Junko from Japan. Please start your presentation. Please welcome with the applause.
Nice to meet you. My name is Junko Wada from a visiting researcher of Biochar Research Center at Ritsumeikan University. And I'm also advisor for Minabe Town. So today I'm explaining about Minabe Town new project. So I'm very pleased to meet you all and thank you for the opportunity to make a presentation. My presentation is how local residents and local governments of GIAS site can practice low carbon agriculture in rural area. So today, I report of a case study of Minabe Town of SDGs Future City and Biochar Action. So first of all, I'm introduce Japan Biochar Research Center of Ritsumeikan University. The center was established in November 2022. Our purposes are to realize carbon negative social implementation through the use of biochar to prevent global warming. Second is to improve and realize biochar's environmental conservation functions, carbon storage, and soil enhancement. Third is to develop human resources in the related field. Our research center operates a membership system. Companies, local governments, researchers, and agriculture and forestry workers participate. We also host forums, workshops, and conduct research on biochar. So this is a diagram for social implementation of biochar. In this business ecosystem, it is crucial to establish organization toward social implementation. We have been promoting biochar by creating the system through collaboration among companies and local governments, academic institute, and the public. In terms of the supply of biochar, there are production side. Production side映らないですよね。なんか全然矢印にならないんですけど。Left is a production side. So, production side. Sorry, そうね。Production side with biochar producers and sellers, and the storage side with biochar users in farmland, such as farmers and agricultural corporations. Furthermore, there are various stakeholders, including the companies and organizations, that purchase credit for carbon offset to implement their action for reducing CO2 emissions. This includes several types of management, namely quality management, J-credit management, database management, and brand management. So this is Minabe Town, Minabe Tanabe Ume system. This area was certified as GIAS site in 2015. The site produced more than half of Japan's total ume productions. The system is unique. That has sustainably produced high-quality ume by making use of slopes with poor soil in nutrient. At the top of the mountain, there is a trees. Ubamegashi forest spread out, which is a raw material for Kishu Binchotan charcoal. Farmers in this area has a custom of sowing charcoal in their ume field. This is Miname town. It is located in the southwestern part of the Kii Peninsula, facing the Kishu Sea, 140 kilometers from Osaka, about 2 hours by car. Ume has been cultivated there since the Edo period, which is a few centuries ago. In 1965, the Nanko Ume variety was registered, and its cultivation spread throughout the town. Currently, an annual production of 32,000 tons represents 30% of national output. This is #1 ume production town. Approximately 70% of the townspeople are engaged in ume-related work. So, vision of the town, a comfortable town where people shine in the blessing of the sea, mountains, and the rivers. So, ume is very good for health and food and medicine. So, Miname town has 3 patents related to the health function of ume. So next, I will explain the Cabinet Office, Japanese Cabinet Office policies related to the SDGs. The Cabinet Office launched SDGs Future City certification system in 2018, and by 2024, 206 municipalities have been certified. The SDGs Future Cities are cities that have high potential to realize a sustainable development through adding new values in the 3 aspects: economy, society, and environment. Now, I'll talk about one of the SDGs Future City, Miname Town, focusing on biochar. So I changed the slide, so please see this slide. So this slide shows the process from preparation to certification of the SDGs Future City in Miname Town. Last year, in May, a town resident voluntarily experienced with converting pruned ume branches into biochar. Later in September, the town held a biochar forum. About 80 town residents participated. Following this, town residents established an organization called the Miname Biochar Club. In February this year, Miname Town applied for the SDGs Future City certification and were certified in May. The advanced plan was also selected as a municipal SDGs model project and obtained a grant of over 20 million yen from the Japanese government. So this is a biochar study forum last September we held. So biochar, biochar is a solid material obtained from the thermochemical conversion of biomass at a temperature exceeding 350 degrees Celsius in oxygen-restricted conditions, which is effective for CO2 removal from atmosphere and improve soil condition. After that, a questionnaire was conducted among the attendees to clarify the current state of their awareness and behavior toward biochar. This is a result of research. According to the survey, about half are currently burning pruned branches, but they are concerned about the risk of fire and the hassle of transportation. So about 90% agree that it would be beneficial to establish a system in Minabe town for the biochar production from branches. The reason for this include top reason is enhancing the town image. Second is contributing to decarbonization. Third is improving soil quality, and over half also cited building a sustainable circular agriculture system, indicating a high level of interest among the town residents. So Minabe town has about 649,000 ume trees. So pruned branches are estimated to be about 9,000 tons per year. If the entire amount is converted to biochar, it will be 1,260 tons. And if the entire amount is scattered to ume forest and agriculture field, the total of 2,500 tons of CO2 can be captured in biochar. In fiscal year, last year, biochar was producing using a simple carbonization machine. Simple carbonization machine is this one, and very simple. And but this year, medium-sized carbonization machine will be introduced in Minabe town, and this one, medium-sized. To buy, Minabe town buy this to improve the quality of charcoal and the carbonization rate. So this diagram provides an overview of Minabe town's SDGs Future City, the SDGs model project called Japan's #1 Ume Village, promoting of health of people, communities, and the earth through the Minabe town Ume Learning Commons. In order to become SDGs Future City, cities need to fill out their initiatives in this format: environment, society, and economy. This diagram is too small, so please look at following pages. So this is environment aspect. It is an environmentally friendly ume cultivation and biodiversity promotion to reduce CO2 emission through biochar. Social aspect is a collaboration between farmers and people out of the town who engage in their initiative. Minabe town is doing ume vacation. It is very popular for people live in cities. And third, theme of economic aspect is to improve the value of ume to enhance branding. So time is up, but I'd like to explain this slide. Here are the 3 initiatives that integrate environmental, social, and economic aspect. So Minabe town was selected as the SDGs model project, which consists of 3 primary initiatives. First is establishing SDGs platform, promotion platform with multi-stakeholders within the town. The second is a pink area, launching the Minabe Ume Learning Commons, which includes educational sessions on ume and biochar, well-being, and ume promotion contest. And green area, third is conducting biochar production forum from plant ume branches. So these efforts aim to transform Minabe town into a learning organization and achieve a sustainable economy. So time is up, so I stop my presentation. And it is very important. Sorry, may I explain this one? So, this is a conceptual diagram, the mechanism of biochar production from branch to tree branches. The town hall will organize and implement these sustainable mechanisms. The town produces biochar plant ume branches, and farmers use it for ume forest. By doing so, we aim to make the ume and ume-related products in Minabe town recognized as an environmentally friendly ume production area with low CO2 emission. So we want to build a sustainable circular agriculture system sustainable for Asia site. I stop my presentation. Thank you very much.
Thank you, Dr. Watajunko. Yes, okay, let's move to the next one. The first speaker is Dr. Hao Xuyuan from China. Please start your presentation.
Thank you very much. I'm Si Yuanhe from Institute of Geographic Sciences and Natural Resources Research, Chinese Academy of Sciences. It's my pleasure to stand here sharing some ideas of my research about both the protected areas and agricultural heritage system in China. So let's just move into the first part about agrobiodiversity and nature conservation. I think we're all very familiar with the Convention on Biological Diversity. Actually, not only the natural biodiversity, but also the agrobiodiversity is quite important because it's related to all the genetic species and the ecosystem levels that are necessary to sustain the key functions of agrosystems, its structure and processes. That's why we are doing our doing our best to conserve the agrobiodiversity through a lot of ways, and because it means a lot to us. Because they have like the relative degree of human intervention, it can preserve the suitable habitats for some wild species, and also it can create wildlife-friendly habitats through traditional agriculture and breeding practices. So it means a lot to us. That's why we are taking our efforts to conserve the agrobiodiversity. And for example, we can consolidate the local community resource management system. We can build the legal framework to protect agrobiodiversity. We can create markets for agricultural products. And also we can develop some new conservation mechanisms. And actually, GS is one of them. Although we've done a lot of the efforts to preserve the agrobiodiversity, we can see actually there is a lot we can do. And when as a researcher doing both the protect area management and also the agricultural system management, I can see a lot. There need a lot more dialogue between these two systems. For example, we can see some core challenges. For example, to understand the interwoven natural cultural values and the systematic dynamics of the agricultural landscapes. Also, we need more legal and policy and diversified support mechanisms, such as land tenures, production inputs, agricultural technology extension, you name it. And also the governance system. The protected managers need to move beyond the traditional concept of a fortress conservation, but to collaborate with the local communities, because China is a country with a lot of rural populations around the protected areas who are engaged in the traditional agriculture producers. And the last one is also a very important issue is the landscape approach. Now that is very popular in protected area management and nature conservation. conservation, and it is something that we can talk about later in GS. Since we have found a lot of the needs between the agricultural system and the protected areas, we can actually see that there is a lot more the protected areas can do. For example, recently in China, there is a lack of legislative framework for protected areas. Although we are now setting up our new national park system, there is insufficient attention to the genetic diversity of crop heritage within and around the protected areas. And then we all know that there are lack of communication between the conservation scientists and agricultural biodiversity scientists. These are actually two big groups, but they seldom talk to each other. And then I think probably we need to increase the recognition of the role of protected areas in conserving agricultural biodiversity and vice versa. Conservation of wild relatives within protected areas and protection of the legal varieties and traditional livestock within the landscape level protected areas. And also the concept of biocultural diversity, I think we need more attention to that. Then we have moved to the GS. GS is actually very important, and it has brilliant functions to actually answer the questions of building a bridge between the agriculture systems and the protected areas. For example, it has a lot of the traditional varieties. It has some cultivation as the agricultural wisdoms and traditional ecological knowledges. And the landscape structure is also very important, the landscape stability and diversity of ecosystem services, because a lot of the agriculture or the semi-natural systems are actually based in the natural ecosystem services. And also we have some traditional values. It's also important it has some quite critical social issues like the resource governance system, the management regime, and also it can promote some circular economy. Actually, a lot of the points have been touched on in this morning and during a lot of speeches. And the most important is that GS as a kind of the landscape area-based conservation measures, although a lot of scholars have already mentioned its boundary is not clear, but still it is institute conservation measures. So landscape conservation is quite important and critical to both GS and the protected areas because the landscape scale conservation can more effectively protect the wildlife habitats, provide corridors for species that can migrate, and also we have some administrative boundaries in China and also in other countries, but around the boundary people sometimes share the similar culture, so they can work together to do conservation. We actually have a lot of similar concepts or ideas at the landscape scale, which is kind of similar to GS, and some are applied in the criteria of setting up GS. For example, conservation compatibility. So the land use is actually kind of a continuum from strictly protected areas to highly developed areas. And land sharing and land sparing, I think a lot of them, you are familiar with that. And also the eco-agricultural landscape. They are all quite similar to GS because they may not design to protect natural habitats, but their multiple use of eco-friendly land use way can actually produce some good conservation outcomes. That's why we can move on to the OECMs. A lot of people are talking about OECMs as a very good complementary to the legal protected areas. And also, I remembered attending meetings about OECMs designation in both Japan and Korea, and also already had a speech I think this morning talking about the potential of Koreans' agriculture heritage systems as OECMs, I think. So that's also, we are now talking about GS as potential OECMs in China. And GS is quite important to probably be a very good complementary to the protected areas because it has a very inclusive conservation approach that is quite popular and is being mainstreamed in the protected area management, especially in developing countries. And then the final part is how can we align GIS with China's protected areas? Actually, GIS is a very good model for synergizing conservation and utilization of resources within and around protected areas because it can respect and maintain the reasonable traditional production techniques. It can draw on really effective traditional resources management and incorporate local peoples into monitoring and management. And finally, it can be it can coordinate landscape scale conservation works. Actually, this picture shows the first batch of national parks in China, and a lot of them are quite located in their designated areas or around them have agricultural heritage systems. Like in Hainan, we have the rice. Like in Wuishan, we have the tea, and like in the Sanjiangyuan, the three river source areas, we have the pastoral, the grazing systems. A second, that the GIS can actually enrich the conservation objectives and the methods for national park functional zoning. A lot of people are talking about zoning. It's the same in China because we have to think about all the residents located around the national parks. And GIS, as a traditional way of managing the resources in an eco-friendly way, is quite important to build a very nice park-people relations. It can implement holistic protection of traditionally land use. Actually, we have some of the generally control area in national parks, but we can go to more details about functional zoning to really conserve the agricultural systems that is friendly to natural habitat. We can protect agricultural landscape, managing traditional settlements, conserve agriculture culture with national park management departments, assisting the survey of the tangible and intangible cultural heritage resources because the GIS is actually a system. We can also protect some of the germplasm resources, compatible production methods, and we also from Dr. Zhao's report this morning, there can be a very good value-adding system that the national park can use from learning the GIS system. And finally, we can strengthen collaborative management with multi-stakeholder participation because that is already done in the GIS sites. And finally, we find that GIS can actually contribution to the whole area conservation, based conservation. It's very preliminary research one of my students is doing. She is looking at the spatial relationship between the China National Parks nature reserves and the spatial relationship between them and the GIS sites and some NIAS sites. We can see actually a lot of the GIS and NIAS sites are located in or around the protected areas. So it can actually enrich the types of protected areas because we don't have protected areas designated to sustainable resource use. We only have national parks, nature reserves, and natural parks. That means the forest park, wetland park, geopark, something like that. But we don't have the sustainable use area designated to protected areas. But I think it doesn't matter because we have OECMs. OECMs can open the doors for more multiple functional land use, and GIS might be one of them. So it can actually integrate and optimize the spatial arrangement and management with existing protected areas. But I think we have to do more research. That's why I'm very delighted to hear Korean students talking about the potential of GIS in OECMs. And she set up a lot of the criteria to kind of compare. And actually, I regret not sending my students here to listen to that report, but I think it's a great opportunity that we can share and ideas around Japan, China, and Korea to talk about the potential of GIS itself and from the landscape perspectives, so that we can conserve both the agricultural systems and the valuable traditional culture, and also natural habitat, so we can have a better human-nature relations. That's all for today. Thank you for your attention, and I welcome any questions. Thank you.
Okay, thank you, Dr. Hao Xuan. And we have the final one speakers, and let's move to the next one. Dr. Wei Wei from China. Please welcome with the applause.
Thanks for giving me the opportunity to talk something about terrace landscapes. Actually, in the past years, I mostly focus on natural science, but terraces is, covered human nature system. So I would like to share some research of my team. We all know that with the mountainous regions, we can see many kind of terrace landscapes across the globe. For some like Palestinian regions, we have more than 5,000 years of terraced landscapes. And in many other countries in Asia, in North America, South America, in mountains, mountain areas in Europe, there are many kind of terraces. But due to the, the culture, the cultivation system, maybe the terrace can be very diverse. This some terrace. Last week we have a meeting in Nepal. Also Nepal did a case study in many terraced landscapes in Nepal because it also many covered high mountains. Also in Japan, in Japan and South Korea, there are also many terraced landscapes. And in China, we have also many ancient books recording terraces over more than 3,500 years ago. And also from modern arts, we are painting and taking pictures like that to describe the characters of terraces. So when we focus on terracing, this is a global map of DEM. We can see that more than 1/3 of total terrestrial in the planet were covered by mountains. So in China, we also more than 2/3 of the counties are mountainous regions. And we all know in the past decades, due to the sloping deforestation and the cultivation, you can induce the land and the environmental degradation, causing very serious soil and water erosion and many other degraded environmental issues. So this is publication more than 100 years ago in Science. A scientist from America focused on soil erosion and its remedy by terracing and planting trees. But he is focused on economic value of these terrace contributions. Also, we have many publications in Nature and other important journals to focus on how terrace contributed to the soil and water conservation and the climate change reduction, mitigation, the climate change effects. Also can increase security, especially in Africa. So in China, in the Loess Plateau region, we have many kinds of terraces, different size, different structures of terraces. Terrace generally is a technique to reshape the natural slopes. So maybe reduce, you alter the micro landfall, right? Then affect soil hydrology. There's some terraces in the Loess Plateau of China. You can see different structures, different crops are covered in the terraces. And we also use this method to get first-hand data to quantify how terraces contribute to soil and water conservation and other, like carbon sequestration, plant growth. So we also collect many data, in the field to quantify how terraces reduce runoff and erosion. Generally can reduce sediment by 73% and reduce runoff by 14.2%. And terracing, many other publications also confirm that terracing can be a good solution for sediment reduction and for benefit of soil water conservation especially in the drylands. Generally, terracing compared with natural slopes can improve soil water by 15%. And based on soil water conservation, they can improve the soil quality for nutrient and many other soil organic contents in the soil. And so benefit plant growth, and carbon sequestration in this special region. Another issue will be focused on biodiversity conservation and food security by terracing. This is a case study in Hebei in China, Shexian County. This area also have listed as the heritage list. It's very ancient terrace for more than 800 years. So the system have reached very rich diversity of agricultural species and crop varieties in this region, and it reach the local people, benefit the food security in this region. And we also have many other cases for terracing, like Zhuanglang Terrace in Gansu province, in northwestern China, Gansu province. During the past years, we have constructed many areas, large areas of terraces in this region, and there's also a museum for education. For local young kids to learn how to know their ancestors to construct terraces in this area. And due to the contribution of this person, during the 1975 to 1980, in China, he was promoted as vice premier in China. And also, terracing can contribute to rural economy and development by apple plantation and many other crops to promote the local economy. And we also, in this region, we have very traditional Chinese medicine plants for increased economic value and enrich the local farmers. So the inheritance of terrace agriculture, that from very ancient time, the traditional farming technique. Now we have rural community coherent culture activities and festivals. This is in the Hebei province, the dryland stone donkey terrace culture in Wangjiazhuang in Hebei province. This is the northern part. In southern part, we have paddy terrace culture. I think in many other countries like Japan, we also have paddy terraces. And this terracing can also diversify the agriculture and the local traditional cultures, like the festivals and the customs of local nationalities. Another issue about terracing contribute archaeology. From very ancient times, like early banana cultivation in Australia. This is a case study. And another case study in China is in Mongolia, Inner Mongolia, from Liao Dynasty more than 1,000 years ago, that we found the Asian terraces in this area. So we focus on how terraces distribute at different spatial scales. We use meta-analysis and data mining, to get many sites of the Chinese terrace landscapes and also world terrace landscapes. And we also use such methods to quantify how terrace distribution in China for erosion control and soil water conservation and carbon sequestration. And my students also have focused on terrace mapping in China. And we worked with Tsinghua University to get this map for 2018's terrace distribution. Now my students also focus on Loess Plain region based on DEM and annual data to quantify in the last 30 years how terrace distributed, how terrace constructed in this region. We also quantify the terrace pattern and the slope crop pattern, also for grape production, how terrace affect the grape production pattern. This is another case study by my students for the Gansu province, how terrace distribute, how terrace affect ecosystem services. So there's another issue we can link terraces with, SDGs, like poverty, zero hunger. The terraces can contribute to food security and also for many other, like clean water and climate action by planting trees in the terrace landscapes. We also now is the introduction about some World Congress. We have a World Congress on terrace landscapes. We have several meetings already in different countries. In the year of next year, 2026, we have a conference in Bhutan about the International Terrace Landscape Alliance have been established in more than in 2010. This is the Third World Congress on Terrace Landscape in Italy in 2016. We have several sites to meet each other in different terrace landscape and discuss how terrace contributes to the human and nature system. So this fourth terrace congress in Canary Islands in Spain in 2019. We also have a journal, established journal, the Journal of Terrace Landscapes. It's a new journal. Last week in Nepal, a keynote talk about the resilience of mountain economies and the landscapes. So I think terraced landscape can be a very important solution for such economic development and rural development. Okay, thank you. Thank you.
Thank you, Dr. Wei Wei. Any questions, three? No? Okay, thank you. Actually, at first I was worried about the time limitations, but fortunately we have 10 minutes left. Is there any questions to all speakers or any comments? Maybe we can have 10 minutes Q&A time. If you have any questions or comments to the speakers, yes, please.
ありがとうございます。Professor, this is for the first, sorry, that's just to develop your opinion. You in the last slides, you mentioned the ambiguity of the concept of dynamic conservation, and that dynamic conservation could potentially, in some cases, could damage, could have negative impact on the landscape and so on. What could be the pathway, the way to, in your opinion, to define what is, let's say, positive dynamic conservation and what is negative dynamic conservation? Because, for example, you can visit a landscape which fulfills all the elements, and for example, there is one, the nice elements, the nice criteria for years, but perhaps there are some innovations. For example, greenhouse, or some walls that are used to protect the trees, but the walls have a, they can have colors that can damage the landscape, for example, no? I'm not meaning this. This is just an example of possibilities. But what could be your opinion on to define, a methodology to say, okay, this is okay, we can accept this or not. that is a. Okay, thank you.
Yes, actually in landscape changes and in the GIS program, accepted the kind of dynamic conservation. So you said that, I said also that it's very controversial. Which one is accepted, which one is not. So that's the GIS, I think. And but we don't have to violate the agricultural values as on historical sites. So so we have to more talk, and we have to more exchange our experiences, because it's always controversial. Actually, in Korea, there is a Kumsan Insam farming. Is from natural one to field to paddy field. At the time, the GIS SAG member said, Kumsan Insam is very unique, but in the paddy field is too
modernized.
Yes, too modernized. So they can't. It's very hard to accept that kind of farming is as a heritage systems. So it's very controversial. So it's very interesting, but very controversial. So we have to exchange that kind of experiences for more and more for the future. That's my presentation that I said to you.
Thank you. We still have 7 minutes. Is there any questions or comment to the speakers? Dr. Chi?
I have a question for Wei Wei. I want to ask, what's the, there's the word, the word cultural landscape heritage. Do you know what's the difference between the selection criteria of the word cultural landscape heritage and the selection criteria of GS? Thank you.
Thank you for your question. This actually, during the most past my research, I will focus on natural science, not social science. So it's I think it's a very good opportunity for me to come here to learn from so many researchers focused on social science, as culture, heritage science, like that. So yeah, that's a very good question. I think culture for terrace landscapes in the past we focus on ecosystem services. Actually, ecosystem service is the link between natural science and the social science. So we think more in the future we would more focus on how to link natural science, social science, as well as sustainable development. The culture is one of the very important points to connect these, also the historical value of these landscapes. So I don't know, it's really hard to say how culture, how cultural heritage with culture landscape. I don't know what's the meaning of this actually. Okay, so. I don't know if I answer your question. Okay.
Okay, thank you. Is there any questions or comment to the speakers? No? It's finished? Okay. Before wrap up this session, thank you again to 5 speakers and all the participants of this session. Thank you again. Maybe we will have take 15-minute break, and the next session will be start 2:30. Okay. Thank you.
Good afternoon. Nice to meet you. My name is Oh Chung-hyun. I'm from Korea. I'm hosting this session. The topic of our session is 5 topics, but Mr. Liu Mu-cheng is absent, and so we have 4 speakers, but I have the time of Liu Mu-cheng presentation. I have break time. Each presentation time is 15 minutes. Please keep the presentation time 3 minutes before the end. The maybe lamp, yellow lamp is lighting. Questions about in this session will answered after the full presentation is completed. If you have any important questions, please write it on paper and deliver directly to the presenter. Now, let me introduce the first presenter. The first speaker is Hara Yuji Sensei. Hara Yuji Sensei, present your topic, please.
Good afternoon. I'm Yuji Hara from Wakayama University. And I've been involved in the GIAS committee of this UME system since its application process. So this GIAS site is designated in 2015. So next year we have a 10-year anniversary. So my talk is just, so it's a little bit based on my previous paper. So if you are really interested in detailed methods and results, just please kindly take a look at this paper. So actually already in the former session that Professor Owada already gave several information of this site, but this UME system is located in the central part of Japan, the south part of Kii Peninsula, which is in Wakayama Prefecture, just southward of Osaka. And you could see that kind of average temperature and considerable precipitation, more than 2,000. And then the main products of this GIAS system is this ume. It's just so-called Japanese apricot, which is it's done to the umeboshi. You might know that is Japanese main side dish. Just side dish, but no main side dish. You can see a lot of this one in the onigiri rice bowl as well. But actually, honestly, I didn't like so much this one before involved in GIAS process. But now I honestly could say I love this one. Actually, I can eat. I recommend this to my daughter as well. But you see, this is a very long annual process, and then this processing stage could make a lot of job in the rural areas, so they can hire people to make this because ume. This is Kii Peninsula, the south part. Then zoom up image of the area of the DRS site. Then this is just a brief geologic introduction. It's a very steep slope with very limited flat plain. And also the characteristics, major characteristics of geology in this area is we have a very fragile mudstone layer in the surface geology. It means it's very difficult even to make terrace that was presented by another presenter in the former session. But so that's why this area was not able to make a just rice system actually for a long time. So that's why alternatively they started to produce these ume trees, ume orchard. Then this is what we proposed to FAO when we applying the GIS. Just we have our forest reach, then we have ume orchard in the slope area. Then Barry Bottom we do have also the village and also rice fields and other products. And also we emphasize that we do have a good forest, coppice forest, which could be utilized for charcoal, high quality charcoals. And also we emphasize the importance of Japanese honeybee, which is major pollinator of ume and other flowers in these systems. Then this is draw image taken by me. It looks like very this kind of a schematic model, traditional landform pattern. You see this kind of steep slope, but you also could see so-called modern structure like this one. You have a ume orchard, but on the bottom you have like chemical fiber nets, just that can get effectively the ume fruits by gravity and also hand picking. So in this presentation, my focus is mainly on this kind of balance between traditional structure and also the modern equipments or modern land use in terms of dynamic conservation in the deer site. Then also we have both traditional structure in the back side. That is, there is the hamlets and also a traditional type ume orchard. But in front you have a so-called greenhouse with plastic vinyl, so-called vinyl house. Then also local people is just making, drying the ume fruit for making the umeboshi pickles. So in many stage and in any phase, we could see this kind of traditional side and also the modern elements in our DS landscapes. Then also, this is the drawing image of my student, and you could see several lots of several farming rods or ume orchard plots. Looks like having a well-grown ume trees, but another one is just planted. The another one it just looks like abandoned. So this kind of dynamic land use, depending on that landowner's will, is our central characteristics of our landscape elements. So this kind of dynamic mosaic landscape is our essential in terms of the total conservation and dynamic conservation of GIS land use systems. you could see in the border of the ume orchard and then rich forest, particularly during autumn, you could see a lot of tree species becoming, their leaves becoming very beautiful red and yellow. And this is ume flowering season on February. Could see very beautiful flowers, but also you could have the coppice forest on the ridge. Then this is the point of what I want to emphasize today. Actually, we emphasize in our GIS application process that just traditional structure you could see just behind. But in front, you could see a very large-scale cut field land redevelopment type orchard. So in any place in GIS in the world, maybe the balancing modern and traditional land use and landscape elements is maybe key issue in terms of succeeding the dynamic conservation. But in this area, we do have this kind of two type of orchard indeed. But during evaluation stage of GIS, we indeed tried to bring the evaluators not to this kind of big orchard, but to the traditional one as well, of course. Then first, my student put a lot of effort making a map, this kind of map, indicating the red color is such a big scale cut field orchard, and the pink color is traditional type orchard, and also the green color is the coppice forest, traditional coppice forest. The colors variation is according to the species as well. Then also we try to identify the land use change. We use the past time aerial photographs, then based on the visual interpretation and also using remote sensing techniques, we identified the land use change between 1974 to 2015. Then we realized that even we emphasize the traditional structure of the steep slope type ume orchard, but in local area, in reality, there is a lot of different type of orchards. For example, from forest to cut field type big orchard. And even that valley bottom rice fields is also changed into several ume orchard sites in response to the price of ume. And this is a cost table to different years. Then we focused on these two types, modern cut field development and traditional steep slope ume orchard. Then conducted particularly focusing on grass species. Then we did have an investigation of the grass species and also tree species, and then try to find how diverse the plants in this area according to the different type of the orchard. And also we use the LiDAR technology to detect such a steep slope. And also we use that past map and current map, then identify the cut and fill area in that modern type agricultural areas. Then we did vegetation survey in each traditional site and also the modern site. Then this is a species list. Just let me show you that our statistic results. We found that traditional farm could have much diversity in particularly in the grass species, but even in cut field pilot large-scale modern orchard, they do have considerable grass diversity, particularly in the plot which was managed by farmers a lot of concern about organic farming. So in these results, we could say that cut fill and traditional balance could be possible. Just we cannot say the cut fill is bad. Just balance is important. Then Simpson Diversity Index, we could find that particularly in the spring, the grass species is rich in traditional type of orchards, but in the summer, they do have a similar diversity index. So in this figure also support the importance of balancing the traditional and the modern type of land use. Then summary of vegetation survey, and this is final one. How to balance traditional and modern agricultural fields. There is an increasing trend to a large-scale anthropogenic cut field land development, which promote efficient ume cultivation. Actually, local people very tend to continue the ume cultivation, such a big-scale, flat, modern type orchard in terms of labor efficiency, but nevertheless, large area continue to function as traditional slope type ume. So in this area, still we do have a considerable amount of traditional type as well. So now the balance is very good in terms of dynamic conservation. Then overall, these areas not experience any one-way land use change, just a very dynamic land use change. So what the government or what we can support to local is that just not like support just specific species, not specific species, but the total land use system, which can guarantee the biodiversity in total in this area. Then we do have some new challenge like landslide and etc. So my university, we try to continue the monitoring of this system ahead and then try to identify and monitor the balance between the modern and traditional structure. Thank you.
Thank you for your presentation. Everyone, once more applaud the presenter, please. Next speaker is Lee Seung-jun. The topic is designating the framework for selecting ecological indicator species in the agricultural heritage site. Please, presentation.
Hello, my name is Seung-jun Lee. I am a graduate student of the Dongguk University from South Korea. And today I'd like to present you about how we could select biodiversity indicator species in agricultural heritage sites. And this is the order of the contents I'm going to present. And let's start by talking about the history of GIAS. The GIAS initiative was first launched in the Johannesburg Summit back in 2002. And since then, 86 agricultural heritage systems in 26 countries have been designated. The importance of agricultural heritage system has increased even more since the adoption of Kunming-Montreal Global Biodiversity Framework, because one of their major goals is to conserve the terrestrial and marine wildlife and ecosystem by at least 30%, and that includes conserving the biodiversity provided them as well. The agricultural biodiversity, which is also often called as agrobiodiversity, refers to the variety of animals, plants, and microorganisms which are necessary to sustain the agricultural ecosystem. And now, when we usually talk about the definition of agrobiodiversity, the first thing that usually comes to our mind is the biodiversity of the crops and livestock species, because that's what it practically means. The biodiversity provided by agriculture is something that came into existence by human intervention. But I think it's important to note that the other wild organisms in wildlife is also equally important and needs to be considered. While their direct contribution to agricultural production may be minimal, their presence in the ecosystem itself is crucial and essential for sustaining the agriculture, because they form the structure of food chain and nutrient cycling of the ecosystem. According to some researches, the agricultural biodiversity is mainly divided into two categories. The first one is plant biodiversity, and the second one is associated biodiversity. The plant biodiversity practically just means agricultural biodiversity, something I just mentioned. Species and genetic biodiversity of crops, plants, and livestock. So there isn't much else to talk about. But on the other hand, the associated biodiversity, it includes, it is further divided into two subcategories. The first one being para-agricultural biodiversity, and the second one being extra-agricultural biodiversity. The para-agricultural biodiversity are made of the species which have a positive effect on the agricultural production. And this includes species such as the pollinator species like honeybees, or decomposer species like earthworms, or agricultural pest predators such as eagles or the spiders, all those insects. So, and it's important to note that a certain species that inhabits the agricultural heritage may fall into more than one category of the agrobiodiversity indicator I just mentioned, such as an eagle may be contributing to the agricultural production by preying on the harmful insects and the rats, and being an endangered species as well. Okay. So in Korea, besides the GIAS, there's also a term called KIAS, Korea's Important Agricultural Heritage System. This includes 18 sites that have been designated since the year 2013. But the thing is, there is not much of the public awareness building around the role of the agricultural heritage sites in biodiversity conservation. So the objective of the study is to devise a method for selecting biodiversity indicator species using the existing concepts that many of us are already familiar with, such as the flagship species, keystone species, and etc. And the study area this time is the Sansuyu Agricultural Heritage Site in Gure, South Korea. The Sansuyu is a deciduous shrub that bears edible fruit like the photo on the left side, and is primarily used for medicinal purposes and occasionally for making liquids. The heritage site is located in Sandong village, Gure, and it is a 1,000-year-old agricultural heritage system maintained by villagers who had to find a way to live in an area with not much of an arable land, but with lots of rocks and mountains. This site was designated as the third KIAS back in 2014. The study method I've implemented is the rapid assessment of agricultural biodiversity indicator species. This method was adapted from the rapid assessment of wetland ecosystem services that was, I believe, first mentioned in the Ramsar Convention on Wetlands 2018. By using this method, all inhabiting plant and animal species of a particular agricultural heritage site are assessed to determine their eligibility as indicator species. So we basically give scores to decide whether a certain species can be qualified as an indicator species. So one species must receive at least one high or two intermediate ratings to qualify as an indicator species. And I have to mention that this criteria I just mentioned is not fixed yet and can change, may change as the study progresses. The assessment is basically a stakeholder matrix analysis. So it should involve surveying all the stakeholders of a heritage site, such as the villagers, the farmers, government officials, to quickly and consensually select indicator species to represent the agricultural heritage sites. Now, let me explain how it works. The photo on the left side you see is the Eurasian eagle owl, which is the largest owl species in the Korean peninsula. And it also happens to inhabit Ujin Gumgangsong Pine Agricultural Heritage Site, which was also designated as both the KIAS and GIAS about a decade ago. Now the chart on the right side shows how this species can be rated based on the rapid assessment method. Now, first off, let me explain. As an agricultural biodiversity indicator species, the eagle owl obviously is not a crop species or livestock species, so its value as an agricultural biodiversity indicator is fairly low. But on the other hand, as a para-agricultural biodiversity indicator species, it can prey on some of the agricultural pests, such as rats or other bigger insects. So I think it deserves an intermediate rating as an agricultural supporting species. And as an ecological indicator species, the habitat of this eagle owl overlaps the agricultural heritage area to some degree. So I think it can be given intermediate rating as well. And for the rest of the species types, the eagle owl is a very well-known apex predator bird species of the Korean peninsula, and it also happens to be highly endangered. It is designated as a threatened species by the Korean government. So I think it's safe to say it can get 3 high ratings by being a keystone species, a flagship species, and an endangered species at the same time. So by applying the method I just mentioned, I conducted an assessment on all the species inhabiting the Gure Sansuyu agricultural heritage sites. And this is how the results turned out. Out of the 309 plant species and 171 animal species, 1 plant and 5 animal species qualified as agrobiodiversity indicators. And as you can see on the right side, the list includes a flying squirrel species, the magpie species, and also an owl species called Oriental scops owl. The Oriental scops owl was rated highest with 4 high ratings and 1 intermediate rating, and was considered the most suitable indicator species in Gure Sansuyu agricultural heritage site. And that pretty much is how we can do the assessment of the indicator species in agricultural heritage sites. The agricultural ecosystem is essential for providing ecosystem services to humans and other species. And conserving agricultural biodiversity through the selection of indicator species for each site is very important to sustain the biodiversity that is provided by them. But I believe, and a lot of you might have noticed, that the method I've just introduced is still at its infancy, is a little too primitive to be used in practical studies and researches. So I believe a more advanced, tested version of rapid assessment method to select indicator species need to be developed in further studies. And that's the end of the presentation. If you could give the your opinions on how the study could be revised or improved, I would highly appreciate it. Thanks for listening.
Thank you very much. The question after whole presentation, please. Thank you. Next speaker is Professor Zhang Weijian. The topic is good practice of agricultural biodiversity conservation in GIA site China. Please, presentation.
Thank you.
Ladies and gentlemen, thank you very much for inviting me to be here. Today, I have a talk about agro-biodiversity conservation in GIA sites. My talk will contain 3 parts. One is about how we should do some conservation about the biodiversity in GIA site. And the second is about how Chinese people, government or farmers to do this kind of action in the GIA site, some practice of the Chinese. And the last one, I will give some thinking, some suggestion to do conservation in the GIA site for biodiversity. So what we need to do to protect biodiversity in the GIA site? Let me have a look in China. As we know, China have 22 programs of GIA site, and also so far we have 188 NIA site. Chinese government important heritage sites. So in all of the sites, they are very important for the agro-biodiversity, especially about the land races, the local varieties. We have conducted some collection, identification, and evaluation for the local crop varieties. And we have collected a lot of land races and preserved in the National Gene Bank. Most of the local crop varieties are from the GIA site and the NIA sites. So for the gene bank, for the National Gene Bank, the conservation is very important to get some source from the GIA sites. And the second is about the species diversity. You know, sorry, yes, it's okay, go fast. Species, ecosystem and crop science or the animal diversity. Because of the traditional farming system in the GIA site, and also the natural positive solutions about the practice. For example, the reduce the chemical application, reduce insect application in the field. We have more white animals, white plants in the field. Also, we have more crops in one field. So the species diversity is very high. And the last one is about the ecosystem diversity. For most of the GIA sites, we have very beautiful landscapes. All the landscapes is one unit of the GIA sites. So, no matter for the gene diversity, species diversity, and the ecosystem diversity, they are all significant for agro-biodiversity conservation in the sites. So, how to do the chance for the conservation in the GIA site? First, about the genes diversity. The most important action is off-farmer conservation. Chinese government has issued several big programs to collect the land races from the GIA site. And also some local government, the provincial government, county government make great efforts to collect the land grasses and the local crop or animal varieties from the traditional farming systems. And some enterprises also implement the actions to collect the gene or gene plasm and conserve it in some like gene bank. There's another actions about the gene bank or crop varieties conservation is on farm. In China, in the just side, the government building some geo-identification plant or some like organic products plant for the local crop varieties, and also the government built the authorization standards and the product standards, and make some mechanism for the joint actions of the stakeholders. And the enterprise can, based on the just side plans, to developing the products brand and sign some contract with the third party or with the cooperative. And the third party can sign contract with the cooperative or farmer to produce the traditional foods or traditional products based on the just side land races. So based on this kind of model, from the government, the enterprise, and the community and the farmers work together to preserve the gene plasm. For example, this just side in China, Jiangxi Wanyan rice paddy field. The Wanyan County government built a kind of new products plant, Wanyan Mi, Wanyan rice. And the government and the enterprise together to work together to plant this kind of land races, and also to sell the rice to the market with a high price. The government gives a subsidy to the local crop varieties. This is another model for the conservation practice. This we call the grassroots volunteer on-farm conservation. First, the government promote the NGO to do some conservation with the community or with the farmer. The farmer can sign some contract with the NGO, and then the farmer can plant the land races and to do some exchange of the seed between the farmers or communities. And also the local community can give some supporting to the farmer. So they make a kind of perhaps community supporting the farmer to conserve the local crop or animal varieties. For example, this is some just site in Jiangxi, the Wanyan. This is a cooperative farmer. He rent some land from the small farmer, and he built a cooperative. He plant the local rice varieties, and also he sell the rice to the company or to the market. About the species diverse conservation practice, the government and also the farmer mostly to do some practice for diversity farming system or conservation farm system. For example, in China, the northeast of China, there is a bigger program for private land conservation with the conservation farming system. And also, we have a lot of systems about the integrated crops and animal feeding, for example, rice fish, rice duck, and other systems. And also, in the mountain area, we have agroforest system. All of the systems or farm systems are promoted by the government, by the company. So all of these kind of practice can serve or can protect the species diversity. And for the ecosystem diversity conservation, the most important or most successful model or practice is about agricultural tourism. The government built a platform for the agricultural tourism, and the government input some money from the company, from the enterprise, and the company built some professional tourism facilities. And the farmer is the actor, also is the producer. They work together to do agricultural tourism and to conserve the landscape in the just site. So, based on my observation and also in the around China, the GSI's survey, we can find there are three experiences about the conservation. First is about the joint action of stakeholders. All stakeholders should be work together to make conservation about the biodiversity. And the second is the comprehensive exploration of multiple function theory. The GSIs have not only have the production function, they have a lot of other functions. We should develop or utilize all of the functions together. And the last one is the integrated global development of multiple industrial channels. So last, I will talk something about my thinking about some suggestions. First, we can look at the factor affecting the biodiversity conservation in GSI. I think there's 4 factors. One is about the approach and the potential of industrial utilization of local germplasm. Second is about the efficiency and the benefits of traditional farming technology and the models. And the third is about the development level of agriculture, culture, and the tourism in the just side. And also, the most important is about the knowledge, awareness, and the capacity of the biodiversity conservation, especially about the farmer. The second, based on the factors affecting the conservation, we can summarize some difficulties. The first is about difficulty in the balance conservation and utilization. Second is about the difficulty in coordinating tradition and the modern. What is tradition? What is modern? Which way we should take it? And the third is about the difficulty in monitoring of and the evaluation. Just like Professor or Dr. Lee talked about the key indicator of biodiversity conservation. It's very important and very difficult. So, if we want to do sustainable conservation of biodiversity in the geosite or other traditional farm systems, I think that there are 3 most important issues we should think about. One is the policy innovation and the improvement. The second is about the monitoring and the evaluation system. Maybe we should think about the EBVS, the essential biodiversity varieties. It means the key indicators of biodiversity. What kind of biodiversity we should to protect? Which species we should conservation? How much the biodiversity is good, is sustainable? And the last one is about the capacity building. I think we should to increase or enhance the farmers' capacity. Also, the government capacity. Let's stakeholders work together to do more sustainable conservation of biodiversity in the GIAS site. Thanks.
Thank you very much, Professor Zhang. It's very difficult conditions. Thank you. Next speaker, Professor Liu, is absent, and so because planned times, we take a break time for 10 minutes, please. After 10 minutes, we will meet here, please. Thank you. Ladies and gentlemen, I will start our session. Last speaker is Jo Yuna from Korea. The topic is developing an evaluation frame in agricultural heritage site.
Hello, my name is Jo Yuna. I am a PhD candidate in Dongguk University from South Korea. Today, I would like to present you about developing an evaluation framework for assessing ecosystem services in agricultural heritage sites. This is the order of the contents I'm going to present. Here is the research background and purpose. The GIAS has been active.
I'm sorry, maybe your mic turn off. Yeah, okay, thank you.
The GIAS has been active since 2013, but the management after designation often lack detail and a systematic approach. So it is considered that understanding the ecosystem services provided by these sites is essential for setting measurable management goals and enhancing biodiversity. Ecosystem services are the benefits humans gain from healthy ecosystems. These services include provisioning, regulating, and control and supporting. To effectively manage GIAS, it is crucial to develop a framework for analyzing the ecosystem services which they provide. The goal of the study is to establish an evaluation system. This is to measure the amount of ecosystem services to be used in policymaking and conservation efforts. This is the chart that illustrates how the study is conducted and the methods that was used. The study is divided into two main parts. The first is to select and decide evaluation categories and indicators. And second is to select, a part is to complete the construction of the evaluation system. Up to this point, we have completed the first part of the study. The second part is to be conducted in 4 studies. For this study, the study area includes 18 GIAS sites. In the case of fishery heritage, the nature is different from agricultural heritage, so that it requires additional research. Here are the study results. The first part addresses the process of selecting evaluation category. Evaluation category from various studies on ecosystem evaluation have been collected and organized. I reviewed the categories from MA, TEEB, and as well as numerous studies from the National ES, National Park ES of Korea, and individual researchers. Categories like water use or ecological education were included in most studies, while other categories such as soil formation appeared in only a few specific studies. Additionally, there were instances where two different studies categorized the same category using different classifications. To determine the evaluation categories from those previously collected, we have established 4 selection criteria. The first criteria is institutional relevance. This one decides whether the criteria align with the agricultural heritage system purpose and objective. The second one is representativeness. This criterion reflects the system's characteristics and represents its functions and rules. The third criterion is the ease of data collection. This can evaluate whether data collection is feasible in terms of time, cost, and practicality of indicators. The fourth is applicability. This tells whether the criteria enable the development of realistic improvement measures based on the evaluation results. We applied selection criteria to determine the final evaluation categories. Each category was rated as high, medium, or low based on how well it met the criteria. Then we selected the category with the highest total rating. In the end, we selected 3 pre-visioning services, 4 regulating services, 5 cultural services, and 2 supporting services. Next, we selected evaluation indicators to measure the previously chosen categories in objective way. To select the evaluation indicators, we gathered candidate indicators in the same way we did for the evaluation categories, by collecting data from various previous studies and literature. These are the criteria for choosing the evaluation indicators. The criteria for selecting the evaluation indicators are the same as those used for determining the evaluation categories. However, for the metrics evaluation, we categorize the degree to which each item met the criteria into 3 levels, as shown on the right of table. The higher the level, the better it fits the selection criteria. Here's how we conducted the metrics evaluation. As previously mentioned, there are 4 criteria for selecting indicators: X1, X2, and X3, X4. Each indicator is evaluated under these criteria and scored from 1 to 3 based on it. The intermediate grades, A1 and A2, are determined by referencing the chart on the left middle of the slide. And the final grade is determined using the chart on the right. For example, if an indicator scored 3 and 3 under X1 and 1 under X2, its A1 grade would be 2, as this number corresponds to those conditions. Here are the evaluation results of the metrics. X1 is set as institutional relevance and X2 as representativeness, with the sum of these 2 ratings giving the A1 rating. X3 is set as ease of data collection, and X4 as applicability, with the sum of these 2 ratings giving the A2 rating. The final group is calculated as the sum of A1 and A2.
We evaluated candidate indicators for provisioning services and regulating services, cultural services, and supporting services using the same method. Through the previously explained process, we finally selected the evaluation categories and indicators for the 4 types of ecosystem services. For provisioning services, we use quantitative indicators such as area and number of species to measure the yield of food production, raw materials, and genetic resources. For regulating services, we measure the quantity of environmental regulation on climate change, water quality, air quality, and natural disasters by calculating land cover, vegetation cover, and the extent of the regulations conducted. For cultural services, we assess the value of landscape uniqueness, aesthetic quality, ecotourism, recreation, eco-education, and heritage by counting the number of programs and their participants. However, because it is difficult to fully quantify this aspect, we need to consider conducting qualitative evaluations in cultural services. Lastly, by conducting assessments on habitat quality and counting the number of inhabiting species and rare species. Here is the conclusion. In this study, based on prior researches and the characteristics of agricultural heritage, we established evaluation categories for the ES. And then we selected evaluation indicators to quantify these categories. In the future, we plan to complete the evaluation system by conducting expert focus group interviews on the selected evaluation categories and indicators. Establishing an evaluation system for ecosystem services can help preserve and enhance agricultural heritage by using the results for key monitoring and management, policy development, public awareness, and further research. In conclusion, agricultural heritage sites can be sustainably managed by conducting quantitative assessments of ecosystem services. This approach can also enhance their biodiversity, conserve their cultural and historical value, and maximize their economic potential for future generations. Thank you.
Thank you very much for your good presentation. Now we have complete all presentations for our session. Thank you to all presenters. Let me take a question from floor. If you asking questions, please raise your hand and announce your name. Before asking the question. Yeah.
Thank you. I'm Yvonne Yu, and I'm actually a member of the Japan GS National Expert Committee. But today I have no questions, but I do find a few of the presentations very interesting, and I'd like to give my comments. Can I give comments? Okay. Especially, I find very interesting, Mr. Lee, your presentation on the categorizing agrobiodiversity into core agrobiodiversity and associated biodiversity. It's very useful. I'd like to share because, of course, in recent years we stress a lot on agrobiodiversity, so much so that we don't know how to actually address those associated biodiversity. But your categorization using, I think, Balia's journal has actually pointed out to us we can have, within associated biodiversity, we can have para biodiversity and extra biodiversity. I think that is very useful for us, especially for the other upcoming GS applications. We can actually then have this categorization of core agricultural related biodiversity and associated biodiversity. I think you have pointed out to us very basic but very, very useful way of framing this, and I'd like to congratulate you and commend you on that. But you also pointed out with your presentation the metrics that you're trying to come out with. I think you can actually look at how Ms. Jo Yuna, I think she has used this metric way of calculating the weightage, that you can actually see whether it applies to you. But I would like to ask you a question. For example, you have that metrics and core agricultural biodiversity. If you put high, highly related, medium and low, right? You have 3 categories. Is a high on the core related agrobiodiversity equivalent to a high tick on the associated biodiversity? Are they the same weightage? What would you think? Because it seems to me now you're just taking into account the ticks, but you're not giving weightage to the different categories. And I think that is actually something you can think about, giving weightage to the different categories. That will probably help you to come up with a scoring system. And then in your scoring system, maybe you should have a minimum cutoff, then to decide whether that is an important indicative species.
First, thank you very much for your comments and opinions. One thing I need to mention is that the method I've applied on the presentation I just made didn't take much time to develop. It was adapted from other methods, rapid assessment. So the point of the method itself is to draw a conclusion, draw a consensus among all the stakeholders of the agricultural heritage system as fast as possible. And so maybe the depth of the methodology is a bit shallow, even from my perspective. The reason I put there was only one subcategory for the core agricultural biodiversity, and on the contrary, there were 4 subcategories for extra agricultural indicator species. The reason I did that was to point out the species that are overshadowed by the original crop and livestock species. You know what I mean? Crop and livestock species, we all are aware that they are the main part of the agricultural biodiversity. They're always highlighted, and people get to know them because they are practically like a star, the main part of the agricultural heritage. But people often ignore that there are other organisms inhabiting that ecosystem that can play a role as a supporting player, I would say. So that was the reason. I just wanted to put a more importance to those underrated, overshadowed species by giving them on a more advantageous set. Was the answer good enough? Or okay.
Yeah, I think that's a very good explanation. And if you want to put more focus on those species, I think you can actually, in your paper, stress that and highlight those. But
come up with some sort of a scoring system, a very, very easy scoring system to highlight those things. And I would just also like to just point out that when you look at how important this species is to the whole food chain of the ecology there, sometimes the extra agricultural species may be eating up the good diversity species. So they may be there. They might be a plus, but they also might be a vice. So you need to actually, each species, look at the prey patterns of those species to decide whether this extra associated biodiversity species is actually good for the system or it's actually neutral. So it's quite complex, but I understand that you say that this is a rapid assessment, so you don't want to go into the details, but I think it is a very interesting way of framing, and I would encourage you to make this really a very good metrics methodology. It will really help GS sites to decide the importance of which species to work on.
Thank you so much for your long, thought-out response. I appreciate it. Thank you.
Thank you very much. Good point of Dr. Yvonne. Yeah, thank you. The next question. Yeah, please.
Okay, time is maybe up. A quick question about the last young PhD candidate's talk about culture, services. Lacks the background of culture studies. So how do you quantify the culture system, services? I see several aspects. So how to make the indicator more objective and how to get the real data to quantify the culture system, the services. Okay. You understand?
Excuse me, we have no times. Yeah, and so I think more question and responses individually, please. Next program is 60 o'clock. First floor in Minamo Hall. Please move to the Minamo Hall now, please. And Professor Wei and Mr. Joe, communication with individually. Thank you. Thank you very much.